Okay, in question 9, we're talking about sequences and series. We're given a function that represents the amount of drug left in Alex's blood after a 15 milligram dose. And we're asked to work out how much drug is left in his blood after 2.5 days. That simply means instead of a t, you sub in 2.5. When you plug this into your calculator, your answer works out as 4.18 milligrams. In part B, we're asked to work out, after one dose of 15 milligrams, how long will it take before there's only 1 milligram left in Alex's blood? That means, well, 15 times 0.6 to the power t tells me the number of milligrams that are left. So I want to know, when is this equal to 1? So in this case, once you sub in here, you've got one equation and one unknown, which means you can find t. You should recognize at this point that the unknown is in the power. Whenever the unknown is in the power, we have to introduce logs. So the first thing you got to do is divide both sides by 15. So you're left with 0.6 to the power t equals 1 over 15. And then at this point you've isolated the term with the unknown in the power, so you introduce logs. Now you can introduce log to the base 5 or log to the base 6 or any log, but what I've decided to do is to introduce the natural log ln. It literally just means you stick an ln in front of the left hand side and an ln in front of the right hand side. Now remember, the reason we introduce logs is so that we can apply the rules of logs. I know if I've log of something to a power, I can just bring the power in front. So ln 0.6 to the power of t becomes t ln 0.6. And I'm happy now because there's no more power. That's the whole point of these few lines. To get t on its own, I divide both sides by ln 0.6, so t is equal to ln 1 over 15 divided by ln 0.6. And if I plug all that into my calculator, my answer works out as 5.3 days. So that means that after only one dose, it takes 5.3 days before there's only 1 milligram left in his blood. And that's relevant for what we're doing in the next part of the question. Okay, we're told that after 4 days, the amount of the drug in Alex's blood is 15 plus 15 by 0.6 plus 15 by 0.6 squared plus 15 by 0.6 cubed. And we're asked to explain where this is coming from. What you have to recognize is that if I took this medicinal drug today, in 24 hours, some of the original dose is still in my blood. If I take another dose then, I've got some of it in my blood from the first injection and some of it in my blood from the recent injection. So that's what I'm describing here. The most recent injection was, it said that he's just after taking his 4th injection. So if you're just after taking it, then there's 15 milligrams in his blood from the last injection. From the most recent injection, there's 15 milligrams in his blood straight away. But he had an injection 24 hours ago. And 24 hours after you take this medicinal drug, there's 15 by 0.6 to the power of 1 of that dose left in your blood. So the second term can be explained as, this is the amount that's in his blood from the second last injection. Or in other words, from the injection that was 24 hours ago. This is the amount that's in his blood from the injection that occurred 48 hours ago. So the second injection was 48 hours ago, and this is how much remains. It's 15 times 0.6 to be squared. So that's what I've said in this sentence here to explain that. And then the first injection was 72 hours ago. It was exactly 3 days ago. So this is the amount of the medicinal drug that's left in his blood from the dose that occurred 72 hours ago. So from part C, we can clearly see that the amount of drug in your blood increases with each dose. It doesn't stay the same, but it accumulates in your blood over a course of time. So we're told we want to work out how much of this medicinal drug is in Alex's blood after 10 doses. Now, you could literally write out the 10 terms and add them all together, but you should recognize that this is actually a geometric series. This is because it's a series that has a common ratio. If I take this and multiply by 0.6, I get to here, multiply by 0.6 again and again and again, that gives me the next term each time. So you have to recognize that we want to use Sn, the sum of a geometric series here. You go to your maths tables, you can take down your formula for a geometric series. It's a times 1 minus or to the power of n over 1 minus or, where a represents the first term, in this case 15, and or represents the common ratio. To work out the common ratio, it's any term divided by the previous term. So I decided to write the second term and divide it by the first term. The 15s cancel and I'm left with 0.6. So then all I did was I want to get S10, so I sub in 15 for A, I sub in 0.6 for OR, and I sub in 10 for N. When you plug all that into your calculator, you work out that after 10 doses, the amount of medicinal drug in his blood is 37.27 milligrams. In part E, we're asked to use the sum to infinity to work out the amount of drug in Alex's blood after a long period of time. So theoretically, after an infinite number of injections, maybe he's been having these injections for 50 years every single day, and what will the amount of drug in his blood be approaching? You have to recognize that this is your S infinity formula. A stays the same, or stays the same. When you plug it in, it works out as 37.5 milligrams. So no matter how many doses, if he has this drug for 100 years, he'll never have more than 37.5 milligrams in his blood. It cannot get any bigger than that. That's the limit. If you take 15 milligrams every 24 hours, you will be close to this value, but you'll never actually get there. Okay, in part F, we're told that Jessica is also taking a medicinal drug, and the amount of drug that's injected each day is D milligrams. And the amount decreases by 15% each day. So if I take one dose, then in 24 hours, 15% of it is gone, and I only have 85% of it left in my blood. So that means after the first dose, you just get D. The D is equivalent to what 15 milligrams was in the first 5 parts of this question. But after a day, the amount left in my bloodstream is 85% of that. 15% of it is gone, so only 85% remains. 2 days after the original injection, the amount left in my bloodstream is 0.85 squared. And obviously, so if I take 3 injections 3 days in a row, the first injection was 48 hours ago, and this is how much remains in my blood. The second injection was 24 hours ago, and this is how much remains in my blood. The most recent injection was just a second ago, so this is how much remains in my blood. I just want you to recognize it's very similar to the previous formula. The first term in this geometric series is D, and the common ratio in this geometric series is any term divided by the previous term, which is 0.85. We're asked to work out we're asked to come up with a formula to describe how much of this medicinal drug is in her bloodstream after N days. In other words, if I wrote out N of these terms, like maybe that's 50 or maybe it's 1,000,000, but if I wrote out a number of these terms, the number of terms being N, then what would it add up to? So I have my A and I have my OR, I'm just going to sub into SN, and relatively easy to get to the answer now. So all I've done is instead of A, my first term, I've subbed in D. Instead of OR, I've subbed in 0.85. So I get D times 1 minus 0.85 to the power of N over 1 minus 0.85. Now, if you plug the bottom of that fraction into your calculator, you'll get 0.15. But I can clearly see, based on the way that I need to write my answer, it's more useful to write it as 3 over 20. 1 minus 0.85 is 3 over 20. Now, I want you to remember, dividing by 3 over 20 is the same as multiplying by 20 over 3. So this second last line, instead of dividing by 3 over 20, that's the same as if I just multiplied by 20 over 3. Hence where we get our last line, 20 by D is 20D, and then I have all of this, but it's all divided by 3. So that's how you go from the second last line to the last line. This is what we were asked to come up with, so that's our final answer. And in the final part of this question, we're told that after 7 days, the amount of this drug in Jessica's system is 50 milligrams. So we're asked to work out what is D, the original dose. How much is she actually getting each day? We have to use our answer from F part I. Sn, the sum of the first n days, is given by this expression. I want to work out how much is in her bloodstream after 7 days, so that just means I'd sub in, instead of an n, I put in a 7. And I know the answer to that question is 50 milligrams. I know that after 7 days, the amount in her bloodstream is 50 milligrams. So if you look at this equation now, I've got one equation and one unknown, so I should be able to just manipulate it to find a value for D. What I did in the next line, I decided to multiply both sides by 3, so 50 by 3 becomes 150, and I plugged the bracket into my calculator. 1 minus 0.85 to the power 7 gives me 0.6794229. Now I just wanted to get 20d on its own, so I divided both sides by this number. 150 divided by that number gives me 220.776. If 20d is equal to that, to get my final answer I divide both sides by 20, and that leaves me to the nearest milligram with d equal to 11 milligrams.